all aggressive.
There's a couple in my neighborhood.
My arm cheese off. We got our practice.
But like it was like 100-pound pack. It wasn't like one of those like little.
That's your next one.
It was like 2 next day. It was next to Keegan Cock's house.
That's right. Let's get our practice out. I love the ones we have already done. So we need to do more. I know it's my fault. You're all excited because you all want to see pictures of Hank.
You should bring him to class.
Bring your pen.
Here we go. This is a no calculator exercise, so we aren't just going to type all this into our calculator. But we are going to recognize when we look at the problem that we have, I mean, look at 4, 8, 16. What is special about those numbers?
They all broken down.
They're all divisible by 4. Okay. What else? They're all even. What else? They're all powers of 2. So 4 is 2 squared. Okay, see what I'm doing? I'm writing 4 as 2 squared. What's 8? 2 to the third. What's 16? 2 to the 4. As soon as they're all the same base, then I can start combining them. So 2 squared to the 5th is 2 to the 10th. We need to remember our properties of exponents. When we have a power to a power, we multiply. That's a multiply right here. And then we have times 2 to the 9. Over 2 to the 16. When I multiply a 2 to the 10 and a 2 to the 9, I add the exponents. So this situation right here is multiplying. This situation is x. And then, when I have a 2 to the 19 divided by a 2 to the 16, I subtract the exponents and get 2 to the third, which we know is 8. So this mess, we change everything into 2's, do our properties of exponents, and we end up with our answer. All right with everybody? All right, number 5. As with most exponent simplification problems, there are different ways that you can start it. Okay? So, Jimmy, are you right here?
I'm looking at it.
Okay. So, one option you have is to get rid of the negative exponents. We don't like negative exponents. So, the 2 isn't moving because he doesn't have a negative exponent. But this guy is going to go to the bottom because he has a negative exponent. This whole shebang has a negative exponent. So that whole thing is going to go to the top. Are you with me? Now, this is equal to what? 2x to the 4th is equal to what? What is that? 16x to the 4th. Well, aren't those going to cancel? So the answer is 32. Right? 16 times 2? 32. home tonight or tomorrow or sometime and redo that problem, you might redo that problem in a different order than I did, just make sure you end up with 32 as your answer. Turn it over. The first one is very, very similar to the one we just did, isn't it? So one option is to take care of the negatives. So what happens to that 5 right there? Says this comes down, and then this whole thing goes up. So we have 5 times. Anybody know what 5 cubed is? 25. There go our x cubed. Anybody know what 5 times 125?
625. Brand do that.
Eli, what about yourself?
I want to do 16 like you.
What?
So better access.
Now, be really, really careful with this problem. You didn't like it yesterday. You might be tempted to cancel, please don't. There is stuff that will eventually cancel, but not in this form, all right? So, one option you have is to think of your numerator as what it is, 5 to the 5th. But then you can think of the denominator as 2 times 5 to the 4th, because that's what 10 is. And then that would mean that you had 2 to the 4th and 5 to the 4th. Now, when these 5s and these 5s cancel, yeah, they're both 5. 5s and 10s don't cancel. But a 5 and a 5, you can. And so you have 1 5 left on the top and 16 left on the bottom. So the answer is 5/16. Yesterday I told you another way to think about that. I don't know that this is the best way to think about it. But when you start canceling, see what happens? You're left with 1 5 in the top and 16 in the bottom. Number 3, tell me what the answer is. Number 3. 64 over 27. That is exactly right. Does everybody get that? Number 3, 64 over 27. The negative flips it, and then you cube everything. 64 over 27. What about number 4?
2 of x squared.
2 over x squared. 2 over x squared. Number 5 is a big mess. Look at it. Those are all powers of 2. So rewrite your 16 as 2 to the 4th. Your 4 as 2 squared. And your 8 as 2 cubed. Is that step okay with everyone? All right, go ahead, finish it. Do the properties of exponents. No calculator, we're doing this without a calculator. What did you get as your answer?
1 over 2 to the third.
1/8? This is not, let's see, 2 to the 16. 2 to the 10 times 2 to the 9. So 2 to the 16 or 2 to the 19. Yep, you're exactly right. 1/8. Good job. Good job. Last one. What does that negative exponent do?
Flip it.
So x to the 36 over 16 to the 1/2. What flips is this? All right, this is what flips. The exponent goes this way. What does a 1/2 exponent do?
That can mean
Means a radical. And in this case, it can be any root, but in this case, it is a square root. Now be careful. Obviously, the denominator is 4. The numerator is not x to the 6th. What is the numerator? X to the 18th. Now, before you start getting confused, what happens to these two exponents? When you have an exponent and an exponent, what happens to them? They multiply. They multiply. X to the 6th squared is not x to the 36th. It's only x to the 12. So your answer is x to the 18th. Okay? All right, let's get our notes out. We gotta finish this up. Yeah. All right. So when you, nice. When you have an exponential, and we talked about what those are yesterday. This is an exponential. When your letter is the variable is the exponent, that's an exponential. Okay? Now, the base of the exponential here is 3. That means that as we go along from term to term to term, we keep multiplying by another 3. 3 to the first, 3 to the second, 3 to the third. Are those numbers getting bigger or smaller? Bigger. This is an example of exponential growth. When your base, this number right here is the base. When the base is bigger than 1, obviously you're going to grow. When you multiply by 2, you get bigger. When you multiply by 5, you get bigger. When you multiply by anything bigger than 1, you get bigger. Does that make sense to you? Now, the opposite of that is when your base is less than 1, like 1/2. What happens when you multiply something by 1/2? It gets smaller. That's decay. Now, this one, you have to really think about because your eyeballs see a 3. You see that right there? What does that do? That turns that into a 1/3, doesn't it? 1 over 3. So this is an example of decay. A negative exponent puts you 1 over. So it isn't 3, it's 1/3. What's this one? That's okay, that one's easy. Now, this one is tricky. That's 3/4. Right, 0.75 is 3/4. But what does the negative exponent do? Flips it and makes it 4/3. 4/3 is bigger than 1. So that is going to be a growth problem. Exponential growth is what you memorize in the BFF. Decay is the reflection of that. Looks like that. Decay. Get it straight. Alright, so bottom line is growth has a base bigger than 1, decay has a base less than 1. Next, find the y-intercept and horizontal asymptotes. What in the world is this? Anybody recognize, not that exact equation, but that type of equation from your BFFs? Anybody remember? It had a 1. This is a logistic function. This is an example of a logistic. So, do you remember what a logistic function looks like? Anybody remember what the logistic is? Yeah, right, Alden had it. It has 2 horizontal asymptotes and it looks like that. Right? So in this question, you are asked to find that point, the y-intercept, and the equations of the asymptotes. Now, you ready for the really good news? One of the asymptotes, the bottom asymptote, will be 0, unless the problem has like a +5 on the end, because we know that that does what? Picks it up. So it wouldn't be at 0 anymore, it would be up at 5. But if you don't have that, if you don't have that vertical translation, your bottom asymptote will be 0. So basically, there are only 2 things to find. You have to find your y-intercept and you have to find your top asymptote. Now, y-intercept is easy. How do you find the y-intercept with anything?
Plug in 0.
Plug in 0 for x. So if I plug in 0 for x, what happens here? What is 0.8 to the 0? 1. So we have 12 over 1 plus 2 times 1. Well, 1 plus 2 times 1 is 3. So my y-intercept is 4. That's my y-intercept. How do I find a y-intercept? I let x be 0. Period. Every time. No options. Plug in 0. Now, the top asymptote, think about what this picture looks like as it heads out. That top asymptote is called your limit to growth. Because isn't it capping the picture? Right? And the limit to growth happens where x approaches infinity. So in other words, think about this fraction. Think about x getting really, really big. 0.8 is is less than 1. So what happens if we take 0.8 to a really big power? It gets really small. And eventually it gets so small, it's essentially 0. Like if you typed in on your calculator 0.8 to the 1000th power, it is minuscule. So this actually becomes like 0. It gets so small. Well, 2 times 0 is still 0. So basically I have 12 over 1. My top asymptote is y equals 12. That number right there, divided by this number, will be your limit to growth. Because this is going to disappear because that number is less than 1. Okay? So let's see if you were paying attention. Let's look at problem B. Can you tell me my horizontal asymptotes? Y equals 0 and y equals 18 over 1 or 18. What about my y-intercept? Remember, you're going to let x be 0. So it's going to be 0, 3. Because when you put in 0 here, this becomes a 1. 1 plus 5 is 6. 18 divided by 6 is 3. You and your partner do the last one. So what are your horizontals? Y equals 0 and y equals 9. And what's your y-intercept?
You flip that?
You don't, remember, we're letting x be 0. So what is anything to the 0 power? 1. So what's in my denominator? 3. So 9 over 3 is 3. Don't get too bogged down. Don't make it harder than it is. Anything to the 0 power is 0. Or excuse me, is 1. Anything to the 0 power is 1. That's Euler's constant. The base of the natural logarithms, like when you ln something, that's all you see. It doesn't matter for the question. You actually know. All right, here we go. Come on, guys. The number of bacteria in a petri dish is given by this number. Is that 0.693T? We're not going to be confused by the way this equation looks. It's got decimals in it, it's got an E in it. Fundamentally, it doesn't make any difference, it's an exponential. These bacteria are growing. The question is, what was the initial number of bacteria present? What? Yes, 100. Now, I don't know how he knew it. How did you know it was 100? That's the initial value. A is the initial value. Some of you, if that doesn't make sense to you, this is always the initial value. Always. But remember, the initial value would be at time 0. Before we start counting, right now, at this moment in time, time 0. If you put a 0 in there, doesn't this become 1? And we have 100 times 1. But this number will always be the initial value. Okay? Now, how bacteria are present after 6 hours. What am I gonna do? Here's my equation. What am I gonna do? Plug in 6. So 100. Anybody know how to get E on your calculator? Second ln. Second ln. So if you get second ln, you get E. And you're gonna raise it to the 0.693 times 6 power. And we get approximately 6,394 bacteria after 6 hours. I'm really gonna need your help on this one. C equals 20 E point 3 zeros, 0001216. Guys, I have really old eyes, I'm having a hard time. Is that 3 zeros, 12116?
Yes.
What was the initial amount of carbon 14 present? 20? Everybody okay with 20? How much is left after 10,400 years? Well, I'm just gonna plug in 10,400 right there. So 20, second ln, point oh.
Gotta get away.
Is the negative not changing?
No, the negative needs to be in there. I opted out with the negative in, and got totally the wrong answer.
Okay.
Okay, it was like barely on it. Why would the negative not make the initial?
The negative doesn't. 20, second ln, negative. Alright, 5.647.
Why does it not make the initial negative 120 or just 120?
Because that exponent has nothing to do with the 20.
It would make the
If I'm doing it on my calculator, I don't need to do that. Alright, everybody okay with 5 point back? When will the amount be 10 grams? So in other words, we want this to be 10.
19.
So 10 equals 20 e to the less. Any idea about that? No. Remember, that was the amount after 10,000 years. We're trying to find how many years it takes to get to that. Now, I'm not interested in trial and error, kids. That could take a while. When you think about a way to do this, Ryan, dividing by 20 is a great idea. Give me 1/2. Okay, now I'm not multiplying, but yes, Ryan, you're exactly right. Ryan is remembering his algebra too. His teacher will be so proud. His teacher from last year. We're going to take one option is to take the natural logarithm of both sides. ln. Take the natural logarithm of both sides. Do not do that until after you divide. Make sure you do the division first. So on this side, we have ln 0.5. these cancel. ln and e are inverses of each other, so they cancel out, and all we have left is 0.000, 0.260. So ln 0.5 divided by negative 0.006. And I got T to be about 5,700 years. ln 0.5 divided by this number. We're dividing both sides.
Yeah, that's what
If you have an old calculator like mine, make sure that when you get ln 0.5, that you close those parentheses before you hit divide by. So that is one option. For me, that is the fastest option, but there is another option. Could we graph y equals 10? And then could we graph that and see where they cross? You can. But the window is going to be funky, and so that could take you a while, but you absolutely can do that. Figure that out. All right, one more. Letter C. Population growth can be modeled by this equation. Notice, you're not asked to write any equations, they're giving them to you. You're just using them. So 19.875 over 1 plus 57.993 e to the negative. Can you read that number? 0.03.
5005T.
Yeah, you're such a genius.
5005T,
Yes.
is that right?
Yep.
Thank you. P is the population in millions, and T is the number of years since 1800. Okay?
Yeah.
So based on this, what was the population in 1850? So what would we do?
Still 50 for T.
Put 50 right here? Okay, just type it in carefully. I gotta try again, that's not what I got. You're probably right, that makes sense.
You actually try.
What did you do? 25. So,
That is not what I got. I keep getting 1.795. Anybody else get that? Ah, some of you did, okay.
no
You
way.
guys wrong.
Let's redo it the B part.
Yeah, go ahead and redo it.
We're doing the top two or just the bottom?
I've done it twice. So why don't you go ahead and just do the bottom.
Okay.
1 plus 57.993, second ln, negative 0.035005 times 50. Alright, that should be 11. Then you do 19.875 divided by that answer. So use your second answer button. And know this is right.
Did
So
I not put
that's
this exactly in my
million people.
read that?
Remember, P is in millions. So in 1850, there were almost 1.8 million people.
Yeah.
All right, that's A. What will it be in 2010?
So you gotta plug in.
We'll do the same thing, but now what will we plug in? 210. So now you're gonna put 210 right here. So let's all try that again
I
and see.
like reading through. I must have just gave him the wrong answer. I don't like it.
Womp womp.
Okay, the calculator's not giving you the wrong answer.
Did I? 19.875 divided by 1.57.99.
Just kill me.
0.03505. How much is that? 19.9. See?
I got 19.162.
What?
Anybody else get that when you put in 210?
Look, I'm putting that exactly in there. I just think we must have to do the bottom then.
Okay, so here is what Eli's issue is. He is literally typing in, he's not using any kind of fraction capability on the calculator. He's literally typing, which is fine. I don't have that capability, so this is what I think. 19.875 divided by 1 plus 57.99. So the calculator uses PEMDAS, that's what's programmed into the calculator. So when he feeds this to the calculator, it is doing 19.875 divided by 1, and then it is adding all the rest of this stuff. If you're going to type it in that way, Eli, you've got to use parentheses because you want it to divide by the entire quantity. Okay? All right, anybody else now get 19.162 here? Okay, perfect. Last question. What is New York's maximum sustainable population, otherwise known as limit to growth? Look at this equation. This is a logistic equation. How did we find that top asymptote, the limit to growth? Right here, right? So what is the maximum sustainable population? 19.875. All right. Quickly.
Boy, B. Doing homework in the middle
Try to
class.
get everyone to look at him.
Doing homework in the middle class.
I thought it was called homework.
Who did it in class? One of these guys
I want
right
to
here?
point a finger.
What are we saying?
I don't care. Test scores matter, so pay attention in class, sometimes they go up.
Very good.
Here we go, yes.
Here we go.
Now, we talked about this yesterday, I'm gonna talk about it again, I wanna show you. When you said, oh my gosh, this test was so hard, oh my gosh. Problems were.
Yeah, Brayden. I got a 62, but I got the phone.
Yeah, same.
I didn't know.
The motion was
It's actually one more student better than 6
the only question that doesn't have mark yet. I'm working on almost every single question.
I got the second one, right? How did I get minus 1 equal?
You did some kind of arithmetic thing. So, kids, literally the review we did on Friday, or the day before we took the test, the review we did, we found the minimum perimeter of a rectangle with an area of 320. That is the problem we did in class. That problem is on the test with a different number other than 320, and some of you missed it. Some of you left it blank. Some of you had no clue. Pay attention to what we talk about in class, okay? We had a problem on the board. I had a problem. It was this. Some of you missed that. That exact problem was on the test. Different numbers with the same format. Some of you missed it. Every single problem on that test, we did the day before. We did it. So when you're talking, messing around, you're missing opportunities. Okay? You're missing opportunities. I don't know what else to say. Some of you did great. I mean, like, they were all either way up here or down here. I don't know. There wasn't much in the middle. I need those back. You don't need to keep them. I still have Now, you may not be able to now with the concussion, so when you get healed up, you need to do it. Yeah, they add up. And you told me the other day when I was studying in that class that you don't try really hard. You need to start trying harder. You do. And, boys and girls, office hours are available to you. You know you can come in and see during office hours, right? Did I get all these? Okay. All right, well, 3.1 homework, 3.1 is due on Tuesday. Canned food drive.
Ray was really good.
I wrote it down. 12 mega rolls of toilet paper. 12 megas and 12 gallons.
On a Barbaro, actually.
Or regular
You guys are by far the most fraud you've ever had.
What? 5 years. We murdered.
The king of your dad.